exponent right there. The next one, you're going to have your 3 squared in the bottom. We just did 9, so that's why. So when you write it with a base of 3, you're going to have to show you dropped it, so that's why it's a negative exponent. Now we haven't done 27. 27 is 3 times 3 times 3, which is 1 over 3 to the third. So show that it was dropped, so that's why you do your negative exponent. This next one wants us to do 2 things. They want us to do a base of 2 and a base of 4. So I think I'll start with the 4. So what we're going to be doing is looking to write these problems with a 4 and then your exponent. So 16 can be 4 times 4, so that is 4 squared. Now 8, yes, you can do 4 times 2, but there's no way to show that when you're doing just one base. So in this case, we can't use a 4. 32, same thing. You could break it up as 4 and 8, and then yes, you could break this one up as a 4 and a 2, but that 2 is kind of like an outlier, so it makes it so you can't show it as a base of a 4. Now this one is one we have done a lot. Think about it. If you have 4 to the 0 power, it's 1. That rule was anything to the 0 power is 1. Okay, so now let's go back, do the same problem, but they want us to do it with a base of 2. So that means we're going to have our 2 here and then some kind of exponent. So these are kind of helpful that we started. We can break this 4 up to 2 times 2 and this 4 to 2 times 2. So that would be 2 to the 4th power because I have 4 2's down there. This one, it's 2 times 2 times 2, which would be 1 over 2 to the third. But remember, we want it just with a base, so we have to show we dropped it, and we'll just add that negative exponent to show we dropped it. 32, you can say 4 times 8, and then you can break this 4 up to 2 and 2, and this 8 is 2, 2, and 2. That's a lot of 2's. So that's really technically 1 over 2 to the 5th, which we want it just to have a base of 2, so we have to show we dropped that 2 to the 5th in the bottom, so that's why you add your negative exponent. And the same thing over here, 2 to the 0 power, it's 1. All right, now your goal on all of these problems down here, first off, it says without a calculator, is to get the same base. So if you look at this number 9, they have the same base. They're both 2. So when they're the same base, you can mark off those bases, and what is left is either your problem or your answer. So my answer would be x equals 5. The next one, they do not have the same base. So I'm going to go ahead and leave this as 3 to the x power, but I can rewrite 9. We've done 9. We did it up here on number 1. We know it was 3 squared. Now you'll notice you have the same base. Mark those bases out. What's left is x equals 2. And that is your answer. Next one has the same base. Mark off those 5's. What's left is your answer or your problem. Sometimes you're going to have to be working some of these. So this one is x equals 2. Now this one has the same base, But hopefully you realize there's an invisible 1 up here because that's 6 to the first power. So when I mark off my common bases, what's left is x equals 1, and that is my answer. So they're super easy when you already have the same base, but you'll know that you're going to eventually have to change some more. So look at number 13. We, did we do an 8? Well, we did an 8 down here. 8 is technically 2 to the third. Equals, bring down your 2 to the x power. Mark off those common bases. What's left? X equals 3. Next one. Not even close. They don't have the same bases. Let's try using a 4 here. 16 would be 4 squared. You have an x up there already. Leave it. Then you have equals 64. Did we do a 64 anyway? We did not. 64 is technically 4 to the third. So now you have the same base, so I'm going to mark off those 4s. What you have left here is this 2x equals 3. So here's the first time we're actually going to have to solve something. So if you have 2x equals 3, we're going to divide both sides by 2. When I divide both sides by 2, I get x is 3 halves. Okay, next one. If you think about it, in a way you want to leave it 4 to the x power. But there's no way, because we tried it up here, there was no way to get 32 using a 4. So we can't use a 4 for that first one either. So we're actually going to have to change both of them. So I'm going to change this 4 to 2 squared and leave the x that's already up there equals 32. We did it before. It's 2 to the 5th. So when you mark off your common bases and you see what's left here, it's 2x equals 5. So we're going to solve that. 2x equals 5. Divide both sides by 2. And then I get my final answer. X is 5 halves. Okay, let's do one more. This one looks a little bit different. Before I start doing anything, I want to get rid of that random 3 that's on the outside. Instead of dividing both sides, instead of multiplying both sides, I'm going to divide both sides by 3. When I do that, these 3's cancel, and I'm left with 25 to the x power equals 15 over 3 is 5. They are not the same base, so I am going to have to change them to the same base. Well, 25 you can change to 5 squared, but you already have an x, so I'm going to go ahead and leave that x there, and this would be 5 to the first. I have the same base, which is really good, so I can cancel those bases. What's left in this problem is 2x equals 1. So I am now going to solve that. So I have, 2x equals 1. Divide both sides by 2. And x is a half.